Alright, so today we're going to look at the difference between accuracy and precision and what that means in relation to physical science, and particularly how you use certain instruments and measuring equipment in a lab setting. So I kind of want to use this analogy with these shooting targets right here to kind of demonstrate the difference between the two. And so let's say you're going to the range for archery or whatever it may be, and you take 3 or 4 shots, and let's say we'll start with this one right here. Let's say you take 3 shots and line it up, and you take aim and take your shots, and you get first one shoots here, and second one shoots off target, third one shoots right here, and then you take a 4th shot, and let's say that you get right here. All right. Now once we look at our 4 shots, we determine that we got 3 that are on the target, but we're not really close to the bullseye. That's kind of what the definition of accuracy is. Accuracy refers to the closeness of a measured value to a standard or known value. So we're trying to get our shot as close to the bullseye as we can be. Now the difference between accuracy and precision, don't get those mixed up, is precision refers to the closeness of 2 or more measurements. More so about consistency. You want to try and make sure that your shots are hitting the same place. So let's take a look at another example. Let's say you make some adjustments for your bow or whatever, and you take 4 more shots. And next time, let's say that you line up. Let's go here. Number 2. Let's say you hit around here. Number 3, hit there, and then number 4, right there. Okay. So in this case right here, if we're looking in relation to where the bullseye is, we're not close to the bullseye. But when we look at our shots, we can see that our shots are hitting pretty much dead on in this spot right here. They're all pretty close to one another. So that's when we're looking at the definition of precision, is have 2 or more measurements that are very close to each other. If we could use terminology to discuss or describe what's happening in these illustrations, this first one we'd say that we have low accuracy and low precision. In our second example, we'd say we have low accuracy because we're not very close to the target, relatively speaking, but we do have high precision. So let's reset again. We make some more adjustments, trying to dial in closer to our bullseye right here. And let's say we take a shot. First one is here, second shot's here, third shot's here, 4th shot's here. And you can see now we're hitting around the bullseye, but our shots are kind of spaced out a little bit more so than, let's say, right here. This example, we could say that we have high accuracy, but low, or maybe you could even argue medium precision. But we're getting close. So let's say we wind up, make some final adjustments, and then we get boom here, boom, boom, and then boom. And that's what we're looking for. After you finally get dialed in, we say we have high accuracy and low precision. Okay, so that's kind of the difference between the two. Again, accuracy is how close we are to the target, and then precision is how consistent we are. But for the most part, we're not doing any archery in physical science. So how can we relate this to something that we may do in a lab setting? So I've got a kind of a question here we can look at to kind of determine what's happening. You can see that right there. It says 3 students were tasked with trying to find the density of an aluminum cube using a ruler and a triple beam balance. Their data was collected and organized in the table below. So this is something that you could do in a physical science lab. It says after the task was completed, the teacher revealed that the actual density of the cube was 2.699 grams per centimeter cubed. Based on this information, it could be concluded that student B's data has, and then we've got our 4 answer choices. All right, so if we're breaking down this problem right here, we can see that the actual density, all right, or our bullseye, our target, is 2.699 grams per centimeter cubed. So that's our bullseye. We're trying to see how close we are to this target, okay? And specifically in this one, we're looking at student B's data. So we're not even worried about student A or student C. All right, so we look at student B's data. Student B, he's got 3 trials, 1.532, 1.525, 1.562. His average is around 1.540. So, in this setting, are we looking at his data? Is his data close to the target? Compared to A and C and looking at our actual value, no, I would say not. He's got very low accuracy. So right off the bat, we can eliminate A and we can eliminate D because he's not close to the target at all. Now looking at his answers, is he consistently getting around the same measurement? And based on his data at 1.5, 1.5, 1.5, I would say so. I'd say he's very consistent in this one. So I would probably, that would knock off B right here. So my final choice would probably be C, low accuracy but high precision. And again, because his average and his measurements are not on target at all, but they're consistent. He's consistently getting 1.5 something, 1.5 something, 1.5 something, and it's very close to his average. If you wanted to take a look at the other data, you could say that student A probably has the highest accuracy and somewhat high precision, and then student C over here, he's kind of all over the place. He goes from 1 to 3. He's not very accurate and definitely not consistent, or doesn't have a lot of precision. So I hope that kind of breaks it down for you, and hope that helps you better understand the difference between accuracy and precision. Thanks, guys.